Okay, so if you remember, we talked about derivatives. So we learned that the derivative of a function at a point A, at a given number A, is defined to be the limit of f of A plus h minus f of A divided by h goes to 0. And I motivated you why this limit is actually important in the first place. Yes, we talked about the notion of finding the tangent line that Leibniz was working on. And we also learned the Newton's perspective. It was interested to find the instantaneous velocity of a moving particle. And then both of these two apparently different problems became related to the same concept of derivative. Okay, so this limit both appeared in the Leibniz investigation and appeared in Newton's investigation, even though they are completely apparently unrelated things. Yes, unrelated subjects. Okay, so then when something like this happens, it means that there is a deeper meaning to this limit. And when this happens in mathematics, mathematicians start giving this a name. This limit was called the derivative of the function at point A. And then they start exploring the derivative of functions. Of course, you had some experience we had from the previous session. You saw that calculating this limit in general is tedious, and sometimes it becomes impossible if the function is a little bit more complicated. So the next step is that, is there any way to circumvent that and try to find a shortcut to be able to find the derivative of functions at given points? Okay. And then I would say that more or less all this chapter is related to this idea that we want to explore the different differentiation techniques of finding derivative of functions. I don't remember if I had mentioned this in this class or not, but if I have a function, the process that I do the derivative is called differentiation. But the final product is called derivative. Okay, so I just want you to know the English word for this process of taking the derivative is called differentiation. Okay. So now we want to concentrate here. I have a type of different functions, and I want to know what would be the derivative of those functions. Of course, if I want to do this thing randomly, it's not very helpful. So mathematicians started to realize which type of functions are happening more in mathematics and categorize them and try to find different rules for them, and then the rules for them, and tabulate them so that if we need, we can use this table. Okay. But before talking about individual functions, there are some rules that if I have two functions, I can combine them in different ways. I can add them, subtract them, multiply them, divide them, raise it to some power, yes? So these are the rules that I want to talk about first. And everything that I am talking here is exactly what I have talked in Math 3C, okay? I'm just reminding you. So here, the first thing that you need to know is that, let me change this formula a little bit. If I want to find the formulas for derivatives, it's better to replace a with x, because I want to take the derivative of f of x, yes? So if I replace it with that, it becomes f prime of x is equal to the limit of f of x plus h minus f of x divided by h when h goes to 0. So what I have done here is just replace a with x, okay? One thing that I want you to know is the sum rule, yes? What is the sum rule? It tells you that if you have two functions f and g, if you add them, and if you want to take the derivative of the sum, you are allowed to take the derivative of the first one, take the derivative of the second one, and add the derivatives. So this is the sum rule for derivative, yes? There is another rule. If, of course, this is not only for two functions, you can have 3 functions, 4 functions, any finitely many functions that you have, they have added. If I want to take the derivative of that sum, I can take the derivative of each individual function and add them at the end. The same is true for the difference of two functions. So if I have f minus g, I want to take the derivative of that. It becomes the derivative of the first one minus the derivative of the second one. So that is the difference rule, yes? But you shouldn't draw this analogy even further. So what I mean, so let me write it with red. So let me write the correct one first. So number 3, if I have a constant c and it is multiplied by my function f, okay, and I want to take the derivative, then I can take the derivative of the function, just simply ignore this in my head, and then after I found the derivative of this function, I can multiply it by c. So here I mentioned that c is a constant. Okay. Before going further, let me just try to motivate you why this formula is correct. Even though in Matrix C, I don't know, for some reason they take this for granted. It's not that. Okay, so assume that we want to understand why this formula is correct. So the only thing that I have in my hand is just the definition of the derivative. Okay, so what I want to do, I want to prove this. I want to prove that if I have f of x plus g of x, and I want to take the derivative of that, it becomes the derivative of the first one plus the derivative of the second one. I just want to investigate why this rule is correct, even though it seems might be very obvious for you, but I'm telling you that this is not trivial at all. That's why this rule works, okay? So what can I do here? If I want to prove it for you, I would say let me call this a function. Let s of x be equals to f of x plus g of x. Okay. My goal is to calculate s prime of x. Yes? I want to calculate, this is s of x, I want to calculate the derivative of s of x, okay? If I ask you what is the derivative of s of x, there is only one thing that you can answer me, and that is using the definition of the limit, yes? So, the definition of the derivative. So it becomes s of x plus h minus s of x divided by h goes to 0, okay? Is that understandable? So here, what I have done, I wanted to find the derivative of the sum, and I am claiming that the derivative is the derivative of the first component plus the derivative of the second. So what I am saying is that let me call this function s of x. I am interested to calculate the derivative of this. So the derivative of s of x, according to this definition, is equal to that. So the only difference is that the name of my function is s. So wherever I see f, I have replaced it with x. Okay, now if I continue this becomes the limit. If I ask you what is s of x, it is on the board. So it is f of x plus g of x. It's f of x plus g of x. And then I have a minus sign. So I have to put a pair of brackets around that. So this is minus s of x. But if I ask you what is s of x plus h, it means that you need to go to your function s and replace x with x plus h everywhere. Yes? So it means that I see two x's, I replace this x with x plus h, I replace this x with x plus h. So this becomes f of x plus h plus g of x plus h. Okay? And then I have division by h goes to 0. So this is the definition of the derivative, and I have used it for Sx. Now you can multiply this negative sign inside and take the negative f of x with this one and take the negative of g of x with that one. Yes? So what you can write this is the limit f of x plus h minus f of x plus g of x plus h minus g of x. Yes? So I can put them in separate pairs of brackets. Divided by h goes to 0. Okay? But now I can divide this separately and this one separately by h. So this becomes the limit of f of x plus h minus f of x. Yes? Divided by h plus the same for g. Okay, and then the limit of a sum, it's also a theorem. You can write it a limit of the first function plus the limit of the second function. Now, if I ask you, what is this limit? It's clear, this is on the board. It's the derivative of f. And if I ask you, what is this limit? It's a derivative of g. And it means the derivative of f is being added to the derivative of g. So this becomes the derivative of f plus derivative of g. So you see, it is not that trivial that this works, but this is working. So this you can immediately prove yourself if you want an exercise. This is at the level of your knowledge, but this is not mentioned for these cases in the book. They have mentioned it for the more complicated cases. But anyway, you can, if you want to have some practice on this, even though I will not give you questions of this type in the exam, you can do this for this one and you can do this for this one. But then I hope that you realize that something strange will go on if I have the product of two functions. Yes. For example, so what I'm saying is that you might draw this analogy a little bit further. You might conclude wrongly that if I have the product of two functions, I can do the same thing. I can write f prime and I can take g prime and then I multiply them. Yes? So I think it's better to write it and take it over. And that is one important lesson in Math 4, which is not in Math 3C. We will talk about this. That would be called the product rule. Okay? So the derivative of the product is not the derivative of the first one multiplied by the derivative of the second one, even though the derivative of the sum of two functions is equal to the derivative of the first one plus the derivative of the second one, and the same for the difference. And another formula that we will learn, these are two important parts of lesson this year, is that the derivative of the quotient of this fraction, if you think that this is the derivative of the numerator, derivative of the denominator like that, it's better also to write it in the notebook and cross it over. So these two formulas are not correct. This is one lesson that we will later come to it. This is another lesson. This is called the product rule. The correct answer to this is called the product rule. The correct answer to this is called the quotient rule. So for the time being, don't take these things for granted, okay? And I hope that you realize what that thing is going on. For example, why this is not going to work. Assume that I want to do the same idea, but for the product of two functions. So let us see what happens. If I assume that, this is not correct, of course, but assume you pretend to want to show this. Let us see where the problem lies, okay? Assume that I have a rough guess, a conjecture, then I want to see if this is true or false. So, okay, if I want to follow the same analogy, okay, so this would be the case. This will be exactly the same. But then when I want to write it here, this will be a product, and this will be a product. And then the good point about sum was that I was able to put them close together, and one part made the derivative of f, the other part made the derivative of g, and I was able to decompose it. But if I have a product, it's clear I cannot do that, yes? I have f of x plus h multiplied by g of x plus h minus f of x, g of x. I cannot take this f and put it next to this, take this g, put it next to this. It is not possible algebraically, yes? So that is the problem. That is why the rule is a little bit more complicated than what you see. We will learn about that later. But here, you need to understand, it is not hard to understand, that the simple algebra, which was possible for the case that I have addition, is not possible if I have multiplication. Yes? Okay. So these are some rules that are very, very important. We will see what will happen for this, what will happen for that, and what will happen if I raise a function to some power and I want to take the derivative of that function. Okay, this is one point that I want to mention. Questions so far? Is that clear?
Yep.
Okay, so only I have three rules now, right now. Okay, so now let us go, let me ask your opinion now. So now you want to start to categorize the derivatives of functions. If you were a mathematician yourself, how do you start to do this? Yes? So you need to have a systematic way somehow to categorize the functions involved in mathematics, yes? So, for example, what would be the simplest possible function that you can imagine? So let me make a table here and try to complete it. So here we have this f of x, and then I write here the derivative. This table will be given to you in the formula sheet, okay? Together with these formulas. So these are the general rules. But now here, I want to talk about particular special type of functions, yes? So if I want to write something on top of this list, what is the simplest possible function that you can imagine that can appear in mathematics?
F of x equals a constant.
A constant. So f of x equals to a constant. C is a constant. Is probably the simplest possible function. It doesn't do anything. So f of x equals to 5 is a constant function. If I ask you what is f of 10, the answer is 5. If I ask you what is f of 5, the answer is again 5. What is f of 2? The answer is 5. So regardless of the input, the output is always 5. So that's called the constant function. Okay? And if I want to draw the diagram of a constant function, the diagram of a constant function is a horizontal line, yes? So in this case, the diagram of a constant function, so this, if this is 5, the diagram of this is y equals to 5. So that's called a constant function. And you remember something from Math 3C that somehow, even in this case, because we realized that what was the derivative, if I have the position of a particle, of a moving particle as a function of time, the derivative, the idea, we realize that the derivative is the instantaneous speed. But if you think about the speed is the rate of change of position of the particle, yes? So Another idea, another intuitive idea behind derivative is the rate of change of a function when its variable is changing. Now, if you have this in mind, can you tell me what would be the derivative? What is the expected from the derivative of a constant function? It's supposed to be the rate at which the function is changing, going up and down. Yes?
0.
0, because this function is a constant. It doesn't go up, it doesn't go down. So the rate at which the function is changing is 0, because the function is not changing at all. Okay, so that's the derivative of this is 0. Remember, the derivative of any constant function is 0. Only a constant function. Okay, but we can in principle prove it. I want you to learn these stuff. They are not hard, but let me prove it. I have the function f of x equals to a constant c. My goal is to show that the derivative of f is 0. Of course, that is intuitively correct, but this is not a rigorous mathematics. So what you need to do, only use definition. This is the only definition at our disposal for calculating the derivative of different functions. So what I do, I would write the definition. The definition here is on the board, but let me ask you, what I can write instead of f of x in this case, because f of x is c, I would write minus c. But what can I write instead of f of x plus h for that particular function?
C.
C again, because that's a constant. So it doesn't care about the input, the output is always c. And then you know that when h goes to 0, so this becomes the limit of c minus c is 0 divided by h goes to 0, but this becomes 0. The denominator is exactly 0. The numerator is an infinitesimal, is a very small number. Exact 0 divided by a very small number is 0, so the limit is also 0. So that is the mathematical proof of that every constant function, its derivative is equal to 0. Okay, now let us make the function a little bit more complicated. So another function which is good to talk about. Can you talk about, so what do you think would be next in this list?
F of x.
Yeah, f of x equal to?
X.
X itself, yes.
Oh, sorry, yeah.
Yeah, f of x is equal to x itself. So let me write this here. And let me talk a little bit more about this. Assume that you don't know this and you want to calculate the derivative of f of x. So what should I do? So now my question has changed. The derivative f of x is equal to x. I want to answer what is this. So f prime of x is equal to the limit h goes to 0. Okay, let us go back to the definition. Instead of f of x, I can simply put x, because in this case f of x is x, so it becomes minus x. Okay, can you tell me what can I replace here instead of f of x plus h this time?
X plus h.
X plus h, yes? So if you don't understand, please let me know. I just write this down. Okay, and then what happens, you see, this h and this x and that x are canceled. Then this becomes h over h goes to 0. But h over h simplifies to 1. So this becomes 1. The limit of 1 is also 1. So the derivative of x is equal to 1 here. Of course, I will rearrange this a little bit later. But now you realize the derivative of the function f of x equal to x. This is called, there is a name for this function. That's called identity function. So it means that whatever you put in, your function gives it back. So it's identity function. It doesn't do anything with your given input, yes? It just returns it back. This function is called the identity function in mathematics. Okay, so the derivative of the identity function is the constant function f of x equal to 1. Is the constant function 1, yes? So the answer to this now becomes clear. So this becomes 1. But of course, we can now do better. Yes, if I right now ask you what is the derivative of this function 5x plus 10, you can immediately answer this question. Of course, you can go back and use this original definition to use the same to do the same thing and get the answer. But you can also combine these rules that you see here with one of these formulas here that we have. We two of these formulas. Okay, so what should I do? I don't, so let me just describe everything, because in Math 4, it's very important to have an understanding on what you are doing, because otherwise it becomes extremely hard. Okay, so I'm just warning you, please try to pay attention for what I'm saying right now, even though you might be impatient and you want to do it quickly, because this is very trivial. Okay, but I want you to understand, if I want to take the derivative of this function, I think in this way, even though I don't write it in that way, I write it quickly. So if I want to take the derivative of this function, the way that I think, but I think it immediately, is I want to take the derivative of this function. But now I see the sum of two functions and I want to take the derivative. So the first rule is rule number 1, the sum rule. I have to use the sum rule. It becomes 5x, the derivative of the first function, plus the derivative of the second part. It's important to realize this process. And for the second one, I don't have any problem because I have a formula in the table. Whatever the constant is, its derivative is 0. So the derivative of this is 0. But what the derivative of this part? I need another rule. It's important to realize that if these rules are not there, this simple calculation is not correct. So I need the third rule here. I have a constant. In this case, it is 5. And I have a function f. In this case, it is f of x equal to x. And I am interested in calculating the derivative of this product. So I have to use rule number 3. So let me write here. From here to here is number 1. From here to here is number 3. It means that I don't care about 5. I only concentrate on taking the derivative of x. And then I have the derivative of 10. So rule number 1 is used. Rule number 3 is used. And now 2 formulas from the table are going to be used. The derivative of x is 1, so it becomes 5 times 1, plus the derivative of 10 is 0, and you get 5. Of course, I want you to not write this at all. If I ask you what is the derivative of this, you immediately answer 5. 5 is correct, but I want you to understand many things are involved that you are not probably appreciating. I want you to start appreciating them. If you don't do that, then you will be in big trouble. Okay? So if I ask you, what is the derivative of that? I want you to immediately answer me 5, but I want you to understand rule number 1 and 3 are applied, and 2 formulas from the table are also applied. This understanding is crucial for Math 4. Any questions here? Yes? Okay. But now, of course, you might ask, what is the derivative of x squared? You might ask, what is the derivative of x cubed? And you can play around. What is the derivative of x to power 1/2? What is the derivative of, don't know, x to power square root of 2? All of these questions are actually relevant questions. And in principle, mathematicians should have an answer for that. And of course, they have it. But sometimes proof of them for you is not at the level of Math 4. But I just want to see what is going on for another step. So for example, I will modify this table a little bit. I will clean and write it a little bit better. So you might ask, the next harder question, the next harder function is x squared. Yes, I'm just trying to see that. But then of course you might ask yourself, I cannot, because if I calculate x squared, there is no guarantee that I know the rule for x cubed. There is no guarantee for knowing x to the 4th. So it means that in principle, I should do them one by one. Of course, there are infinitely many of them. So might be it is hopeless. But fortunately, this is not, yes. So if I want to let me calculate this one as well. So it means that now I change this. This is x squared. And then I want to answer this question. Let us see what would be the main difference. If I want to use the same definition, f of x instead of x is x squared this time. Yes? And then f of x plus h, it means that I need to replace x with x plus h. So this becomes x plus h to power 2. Yes? Okay, so I clean this one. I don't need it. So I need to calculate this limit. Okay, one way to calculate this limit is to expand this expression. So what happens? This becomes the limit of the first one to the 2, x squared, 2 times the first one times the second one, 2 times x times h, then second one is squared, and then I have minus x squared, and then I have divided by h goes to 0. And then what you see what happens, this x squared and that minus x squared are canceled. And then this limit is the limit of 2xh, and I can factor h out and h out, so it becomes 2x plus h, and then divided by h goes to 0. Yes? And now I can simplify this h with that h, and then what is left for me is the limit of 2x plus h. And h goes to 0. And the answer becomes 2x. Because h is my variable, I am sending h to 0. I'm not touching x at all. So it becomes just 2x plus 0, which is 2x. So it means that now I know the answer, which is 2x. But now I don't want to prove it for you because you need to know more things. There is something called Newton's binomial theorem that we will study in Math 5. We haven't studied that yet. Even if we study that one, let me talk about them step by step. So what will be so if I am interested in x3, so let me write here, it's 2x. Of course, another natural question is that what is the derivative of x3, okay? But let us see what would be the main problems here. If my function is x to the 3, I need to start from the definition once again, but what I need to do, I need to raise this one to power 3 minus this one to power 3, okay? So, might be you somehow know the formula for this to power 3, you should expand this, you need to expand it and then simplify it, and then you will see, using the same ideas but harder, you will get this formula, 3x squared. So you realize what would be the main problem in tackling the problem in general case. If I have power 4, then this becomes 4 and this becomes 4, and then I have to raise it to power 4. It means I have to multiply it by itself 4 times. If I have x to power 100, then this becomes 100, 100. I have to multiply it 100 times, which becomes harder and harder, okay? So it means that I need to be able to systematically solve this problem for all possible choices of n. And then this is a very big problem in mathematics. If you want to do it rigorously, you need to do it for natural powers, and then you need to do it for negative natural powers, and then you need to do it for fractions like this. And then you, at the very end, you will be able to do it for something like a square root of n. It's actually a long, long process. If you really want to understand, every one of them is a problem on itself. First, you need to consider natural numbers. It means that I have a natural number here. Then you will have a formula called binomial, Newton's binomial formula. Yes, we can solve it somehow. But then, of course, the binomial Newton formula is not valid if these are negative, if they are fractions, if they are squares. So then what I can do, it becomes a very big problem. But there is a good news. The good news is that all of them, even though the proofs are completely different, it's a miracle that all of them follow exactly the same pattern. Okay, so this is why instead of writing all of them, I will clean them and write the general formula. Okay, so the general formula is this. if I have x to some power a, the rule is to bring a down and multiply it by x to the exponent 1 less. Yes, so let me clean this. And right here, a is a constant. So at least you know what the problem is to prove this formula. For proving x, it was simple. For x squared, it is simple. For x cubed, it's not that hard. You can do it as a practice if you want to, and I recommend you to do that. For x to the power of a natural number n, you can use the binomial Newton's theorem that we will study in the second chapter of Math 5. That's also not that hard. But then the other problems becomes a little bit technical. So you need to know how to deal with that. But the good news is that all of them, regardless of the choice of a that you have here, follows exactly the same pattern. Yes? Any questions so far? Okay, good. Okay, but this is matrix problem. I'm more or less sure that many of you have forgotten or haven't seen this in entirety. So let me try to give examples that we can just use this formula and those simple rules to be able to differentiate. Okay, and then the surprising thing is that there are many of them. We can just do right now. Okay, so that was the point of the next exam. So this is just a complete repetition of Math 3C, everything from scratch. Okay. Okay, so let me write my example here. Example. So let me write it briefly. Differentiate means find the derivative. So number one, f of x equals to 5x to power 3 minus 2x squared plus square root of 2. Okay, I want to take the derivative of this function, and because I hope that you remember a lot of things, so I can do it quickly. But in principle, if I want to take the derivative of this function, I need to use the difference and the sum rule. I need to rule number 3, in which a number is multiplied by my function. And for this one, and for that one, and for that one, I can use these formulas. So then, because I'm more or less sure that you know about this, so let us do it quickly. If this is given in the exam, I want you to be able to do it quickly. So what is the answer? 5 is here, 3 goes down, 3 times 5 is 15. But I hope that you understand why, yes? Because 5 is a constant, you put it aside, you take the derivative of x3 according to that rule, it becomes 3x squared, and there is another 3 here and a 5 here, multiply them, it becomes 15. X to the 2. The next one is minus 4x, and the last one is 0. So that's your derivative. Yes? So number 2. So what happens, for example, for this function? F of x is x to the power of 2 times 2x minus x squared to the power of 2. So let me make this one 3, okay? We want to calculate the derivative of this function. So do you have any suggestions how to do that? If you just want to use a rule, that rule we haven't learned so far. I want you to understand that, because if I ask you what this function is, you would say this is the product of two functions, x to the 3 and this function to the 2. you are not allowed to take the derivative of this one and derivative of that one and multiply them, yes? So it's a product rule. We haven't studied that yet, so it means that we need to find a way out of it without using that. So any suggestions?
Expand it.
Yeah, expand it and multiply it, and yes, and then hopefully you realize that it becomes a polynomial at the end, and you know how to do it for polynomials, yes? So this function at this level, there is only one way, even if you know the, so I would say that even if I know the product rule, it's simpler to do it in this way. So I will write x to the 3, I expand it, the first one to the 2 times the first one times the second one, and the second one to the 2. Still expansion is not finished, so f of x becomes equal to, I expand it, it becomes 4x to the 5 minus 4x to the 6 plus x to the 7. Yes, I have this one now, and everything is ready, so you can immediately calculate the derivative. So this becomes 20x to the 4 minus 24x to the 5 and plus 7x to the 6, yes? That's your answer. So I am focusing on different types. So this is an example, is a very important example, a prototype example. You need to have it in mind. So I'm just giving you all possible cases that this simple innocent formula is useful to solve, yes? So that's one case. Number 3, let me write here. So number 3, let me write it in this form. F of x is equal to x to the power of 2 let me start with a simple one first. Square root of x. Okay, so what is a square root of x? I want to take the derivative. You see that this formula is not exactly in the table. So you need to reduce the form, you need to transform this function into a form that you can see it in the table and then use the formula in the table. This is the skill that you need to practice and learn. To change the form of the given function into a form or a combination of forms such that each form you can find it in the table. Yes? Okay, so what can I do here? I hope that you remember these formulas. So let me also, the formulas that we need, let me add them here. So if you have a square root of some a, you can write it as a to power 1 over 2. And if you have the mth root of a to the n, you can write it as a to the n over m, yes? So these are the formulas. I don't know which one of them is in the formula sheet, but you need to really know them. Okay, so the first thing that I do, I see that this formula in it, this function it's in this form is not in my table, so I realize that I can use this relation to change the form of this function. So the first step is to write x to power 1 over 2. Okay? And then what happens, I take the derivative of this function using this rule. Even though I haven't proven that for you yet, but I told you that if you trust me, this formula is valid for all possible type of exponents. So then it becomes f prime of x is equal to, this 1 over 2 is playing the role of that a in that table. So 1 over 2 goes down, and then I have x to power 1 over 2 minus 1. Let me simplify this. So this becomes 1 over 2. 1/2 minus 1 is negative 1/2, and still I want to simplify it more. I will take it to the denominator and make the exponent positive, yes? So then it becomes 1 over 2x to the power of 1 over 2. But again, what is this x to the power of 1 over 2? Because for our eyes, this is more familiar than this one. So let us change it back to square root of 2x. So this becomes 1 over 2 square root of x, yes? I really want you to memorize this. This is not in the formula sheet. So let me add something here. So the one that I am writing with this red are special cases of this that I want you to have it in mind. So if I give you x, of course, you'll learn that the derivative is simply 1. You don't need to memorize that because you can put a equal to 1 and use this formula to get this. That's correct. And then I really want you to remember this as a special case. The square root of x, it's very important to memorize it. It's not in the formula sheet. So it's 1 over 2 square root of x. If you don't have it in your memory, every time that you need it, you need to do this long process. Okay, so I really want you to remember. I will add one more to it and close it. These are special cases of one more I will add. These are special cases of these formulas that I think they are worthy to remember them separately. Okay. So this is one thing that I wanted to talk about. Now let me ask you this question. This is by my experience, I have seen students make mistakes here. So if I give you this, and I want to take the derivative of this function. Okay, I do it in one way, you can tell me if this is correct or not. I take the derivative in this form. I say that the derivative of x squared, of course it is 2x, I know. And the derivative of the square root of x, I just calculated, it's 1 over 2 square root of x. Do you agree with this way of doing this? No. It's a big no, okay? So let me cross it over. Even though if you ask me, is this wrong? No, this is correct. The derivative of x squared is 2x. The derivative of the square root of x is this expression. I just calculated it for you. But if I write this for the derivative of this one, it's totally wrong. Why? Because this formula is not correct when it comes to a product. This is the product between these two functions. Yes? I am not allowed to take the derivative of the first one and the second one and multiply them together because we still don't know the product rule. But what about this one? Let me put this in a box. If I give you this function, do you agree with me now if I write this?
Yes.
This is a yes. Why? Because now this is the sum rule. The sum rule allows me to do this individually and add them. But the product rule is not as simple as this one. We need to learn it later. So please write this and cross it over if you understand, if you might think that you will forget. I have seen, even though every year I am just telling you this, but probably there is no hope. Okay. So how should I do it in correct formula? So this is the wrong form. Of course, the one way is to know about the product rule, which you don't know right now. But still, you can solve it, and that's, by the way, a Math 3C problem. So what should I do now?
They both have the same base, so you can convert the square root one to power of 1 over 2. And then
Exactly,
you can,
and then use the base rules to simplify this, and then take the derivative. Exactly. Yeah. So every example that I am giving you here are super important. This is sometimes you need your memory for some of them, the tricks and techniques, not this function itself. The idea behind how to solve this function, you should have it in your memory. So if I want to solve that one, as Lucas said, I would write it in this form. X squared is just simply x squared, but the square root of x, we know there is another name for this, which is x to the power of 1 over 2. And then what can I see? I can see that the bases are the same. I have another formula for powers. Hopefully you remember. So let me write them here. So here I have a to power n multiplied by a to power n is a to power n plus n. And I have another one, a to power m divided by a to power n is a to power n minus n. And I have another one, a to power m to power n is a to power m times n. Yes, these are the formulas that are important to remember. Okay, now I use the first one here because the bases are the same. So I would write the base and I add the exponents. And by the way, the exponents has to be precise, exactly 100%. So in this case, which is 1 over 2, you are allowed to write 0.5. But if that's 1 over 3, you have to work with fraction. You have to. Okay, then it becomes x to power 5 over 2. 2 plus 1 over 2 is 5 over 2. So then f of x is equal to that one, and I want to take the derivative. I can do it right now because this is exactly of this form. In this case, 5 over 2 is playing the role of a, yes? So what I do, I take the derivative, I follow the same pattern, the a goes down, a is 5 over 2 in my case, and then it becomes x to power 5 over 2 minus 1, and then it becomes 5 over 2, and then you have to write the exact value. 5 over 2 minus 1 is 3 over 2. And if you want to, it's good to know, you need to have this skill at this third grade to be able to simplify that. Of course, from my point of view, this is done. If you write this in the exam, that's okay. But let us simplify this as much as possible, yes? 5 over 2. Instead of fraction power, I can write it as the square root of x to the power of 3. I'm using this, yes? And then you know that x to the 3 can be decomposed in your head to x2 times x, yes? Let me write this down. But I need to take x out, but x is positive here in this case, because in the function, the square root of x appears. So it means that x should be positive, otherwise the function is not defined in the first place. So this is why I don't need absolute value. But I told you that the square root of x squared is always and always equal to absolute value of x, unless you have a good reason why you want to remove the absolute value sign. The reason that I can remove it is because it appears in the function. If x is going to be negative, so the function is not defined. So it means that if the function is defined and I am interested in calculating the derivative of the function, then I am on the safe side. I don't need to write the bracket, the absolute value sign. So this becomes x square root of x. This is really, I prefer you to be able to stop there, even though for this problem, if you stop here is okay. Any questions? And you see that now you can compare. This is the correct answer. If you do it in this way, it's completely different from that correct answer. So this is wrong. Okay, so let us try to actually play around with this formula a little bit. So number 5, let me give you another example. So let me give you one and wait for you a little bit. Okay, so f of x is, for example, we have 3/3 root of x multiplied by x plus 1 to the power of 2. Okay, I just wait a little bit for you, okay?